I said before that we could write smarter code to do better LED blinks. Well, before we can do that, we need to look at actually what is our code actually doing. So here I am in the Python shell. I'm using Python 3, and I'm going to do some stuff that's very similar to when I write code for circuits, but I just want to run some things through Python to show you what's actually happening behind the scenes. Now, I'm not actually using my Raspberry Pi for this. However, you can do all of this in Python 3 on the Raspberry Pi. So I'm in the shell, and what's great about the shell is that when you type a line, it actually just spits out whatever that line does. So if I say 1 plus 1, I get 2, and if I say something like print hello, it prints the word hello. So the Python shell is a really great way to kind of get an understanding of how the code actually works. So I'm going to do a couple things that I do a lot for circuits, but I'm going to do them here to illustrate what's actually happening. So one of the big things I do is for I in range 0, 5. And I do this a lot with circuits because I want to maybe blink a light 5 times. And what I want to get is basically for each pass through this range of values 0, 1, 2, 3, and 4, which is 5 values, do something. But it doesn't use the last value. It uses 0 through 4 because 5 is like a boundary, right? And to show you that, I'm just going to print out all those values. There they are, 1, 2, 3, 4. Now if I did this with different values, like let's say I did 0, 10, it would print the values 0 through 9, be a set of 10 values, but it wouldn't include the value of 10, the last number in that range. So again, remember that it skips that last value, but by starting at 0, we can look at it and say, okay, 0, 5, it's a range, it'll be 5 values. It's really an intuitive way of looking at it. Now another thing I want to talk about is while loops. So if I set a value like a equal to 0, and I say while a is less than 3, this is going to let me make a little loop that's going to do something every time that a is less than 3. I'm going to print out the value of a first, and then I'm going to make a get bigger. This is going to be useful with circuits because maybe we want something that's going to, react to button presses, or it's going to do something like maybe make a light blink a set number of times that maybe came from the user's input, anything, right? And so what we have here is while a is less than 3, we're going to print the value of a and show you that it's going to go through this 3 times. So it's going to do this for the values of 0, 1, 2, but not 3. Whenever a is equal to 3, this while loop is no longer true and it's going to end. So let's see how this plays out. 0, 1, and 2. So we got the 3 values that we expected, and you can see how a while loop and a for loop can produce a similar kind of thing. So we understand things like plus and minus and division using slash, but what about something like modulo? Modulo is remainder division, and it's represented by the percent sign. And remainder division is really useful when we want things to happen at different rates inside of our circuit, but we need a way to count that. So what I usually do with modulo is set some kind of variable to be a counter, and when that counter hits a certain value, whether it be every time that it's a multiple of 4 or multiple of 5, it's going to do something. So how does modulo help us do that? Well, modulo is remainder division, which means that basically if I do 3 modulo 2, it's going to spit back what's the remainder. It's 1, right? If I did something like 5 modulo 4, it spits back 1. That's my remainder. What if I had something like 16 modulo 10? Well, my remainder is 6. Why is this special? Because if we do something like an interval counter for a circuit so that something happens every 4 times we pass through a loop, or every 10 times we pass through a loop, you can have a conditional that is something modulo that quantity, and it'll follow those rules. Now what's exciting about modulo is that not only does it work for us to set conditionals for an LED to change state every 4 passes through a loop, we can use modulo for multiple LEDs and get 2 different LEDs to blink at different rates. So that'll be a really special thing that we'll look at when we get to a circuit that does that. I also want to show you how modulo can be used inside of a loop. So if I say for I in range 0, 15, I now have a loop that's going to look at every item in the range 0 through 15, right? And I want to say if I modulo 2 is equal to the value 0, meaning that there's no remainder. This will give me every even number. It'll give me 0, 2, 4, 6, and it'll give me 0 basically because there's no remainder for 0. But this is special because it's going to let me actually have every other pass through this for loop. I'm going to go ahead and print out the value of I. Now you may be wondering, why is there a double equal sign there? Double equal sign is a conditional. Just like we use less than, greater than, double equal sign is saying, are these values equal to each other? It's a double equal sign because whenever we set a variable, we use a single equal sign. So if you remember double equal as the comparison and single equals the assignment, you'll always have it straight. So let's see what happens if I say for I in range 0 through 15, I modulo 2, is it equal to the value 0? If so, print out the value of I. I got the values 0, 2, 4, 6, 8, 10, 12, 14, all of the evens, just as intended. So now you have an idea how modulo works, how for loops work, how while loops work. All these things work outside of circuit code, but they're very helpful as we make circuits. So Python can be used for all kinds of things. Right now we're just focusing on it for circuits. Hopefully these new tools will help you developing code of your own. Thank you for watching.